This is 12.3b of geometry. So we're going to continue with the inscribed angles, and here are three corollaries. So this first one, and let me use some colors to show you, says that two inscribed angles that intercept the same arc are congruent. So if we look at angle A here, it goes with this arc. And if we look at angle B, it goes with the same arc, right? So let's say that arc is, how about 100 degrees? I don't know what it actually is, but if that's 100 degrees, then this angle is half of that, 50 degrees. And if that same arc, of course, is 100 degrees, then this angle is also 50 degrees, right? So do you see how those are always going to be congruent? Because they're always going to match up with the same arc. Second one's kind of obvious. If you have a semicircle arc, that goes with a right angle. And our third one says that opposite angles of a quadrilateral inscribed in a circle are supplementary. So let's break that down. Quadrilateral, that's a figure with four sides, right? So here's one. If it is inscribed in a circle, that means that all of these points are on the circle. Okay, they're not out and they're not inside. They have to be touching the circle. Then these angles add up to 180 and these angles add up to 180. So let's give that a shot. We're just going to do our got it problem down here. If I look at angle 1, it matches up with this arc, which is half of a circle, right? A semicircle. So this arc is 180, which means that angle 1 is 90 degrees, right? 180 divided by 2 gives us 90. Right there, I'm going to look at angle 3 for a second, okay? You could either use the fact that these two angles need to add up to 180, right, and do 180 minus 90, that gives me 90. Or again, you can look at the angle and look at the arc. This is a semicircle, which is 180 degrees, so angle 3 is also 90 degrees. So I'm going to look at angle 4 next, because if I look at this angle, it has measurements for the arc. So 60 plus 80 is 140 degrees. So the arc is 140 degrees. If I do 140 divided by 2, we get 70. So angle 4 is equal to 70 degrees. And then these angles need to add up to 180, right? Because they're opposite angles inside this quadrilateral. So if I do 180 minus 70, I get 110 degrees. So angle 2 is equal to 110 degrees. Okay, another theorem. This is going to have the same equation that we worked with inscribed angles, okay? If you know what your angle is, you multiply it by 2 to get your arc. If you know what your arc is, you divide it by 2, right? So that's what this says. Angle is half of the arc. And we also know that arc is equal to 2 times the angle. So it looks a little different, but it's talking about a tangent and a chord, okay? So here's the tangent. Here's the chord. You see this angle that it makes here? We're talking about this angle that goes with this arc. Okay, see how it cuts off that arc? Same thing over here. It's the same deal. It's just a lot bigger. So this is our tangent. This is our chord. So this is the angle we're looking at. And this is the arc that goes with it. So let's try, we're going to do their problem first, and then we'll do our problem. So in the diagram, SR is a tangent to the circle at Q. So here's our tangent line right there, right? If the measure of the arc PMQ, let's mark that. So PMQ, if the measure of that arc is 212, what is the measure of angle PQR? Okay, so we're looking for that angle right there. Well, if we look at these, here's the tangent, and here's the chord. That goes with this angle right here, right? So if this is, and it goes with the green arc there, right? The red angle goes with the green arc. So if the green arc is 212, if we divide that by 2, we get that this red angle is 106 degrees. This is a straight line right here, which means that these two angles have to add up to 180. So if I do 180 minus 106, we get 74 degrees, and that is what this blue angle is right here. Okay, we're going to look at this one as well. Stick with me. It's going to take a little bit here, but if we look at this angle here, okay, this is an inscribed angle, right? The vertex is on the circle, and it goes with this arc right here. Okay, so if this is a 35-degree angle, that arc is 70 degrees. Okay, now I'm going to erase just that angle part. So we're looking for x and we're looking for y. And we're told that JK is a tangent. So here's the tangent and here's a chord, right? So it's going, this green angle right here goes with that yellow arc, right? Do you see that? So if the arc is 70, to figure out the angle, we need to do 70 divided by 2, right? Let me take away the green stuff. 70 divided by 2 gives us 35 degrees. So x is 35 degrees. And we still got to figure out y. So y is the measure of the inscribed angle right there, and it goes with this arc right here. Well, I don't have any numbers there, but if you check this part out, okay, if I look at this with the yellow arc, this is a semicircle, right? This is a diameter going across here. So that pink arc is 180 degrees. So if I do the whole thing is 180, if I take away the yellow part, then I get the purple part. So 180 minus 70 is 110. So that purple arc over here is 110. So the arc that goes with angle y is 110. If I do 110 divided by 2, I get 55 degrees. So y is 55 degrees. So this one's a little more complicated than other ones we'll do, but it shouldn't be that hard as long as you take it step by step and piece by piece, one at a time. And there's your homework.